Okay, crew, so this should help you with problem 49, part A. Again, this lesson, remember, is about building the exact equation given a graph, okay? So for 49, part A here, remember, we're building a polynomial equation. So our equation is going to hold this form. P of x is equal to a times x minus r times x minus r times x minus r. Remember, r is just your roots, okay? And you're going to put as many roots as you want to, right, based on what the graph looks like. Now, this graph only has 2 roots, so we're not going to need a bunch of sets of parentheses here. Okay, this graph has 2 roots. One of them is right here, and the other one's right here. Okay, now, if you look at the root on the left, this is what's considered a double root, because of how it behaves at that spot, right? It looks like a parabola at that spot. This root over here is considered just your normal single root. And how we know that is because it just passes through the x-axis. Okay. So when we build our equation, we have to note that. So now we can build the equation. Okay. A, we still don't know because we don't know how stretchy it is. Okay. We don't know what the stretch factor is yet. That's what this process is about, is solving for the stretch factor. And then we're going to put the roots that we have. Okay, so our first root looks like is at -2. So x minus -2. Okay, that's a double root. So I should see a squared attached to that root. And my second root is at +2, it looks like. So x minus +2. So there's some simplifying we can do. So let's go ahead and do that. Okay, x minus a -2 is the same thing as adding 2. And there's nothing I need to do to simplify here. Okay, so now we've built the equation, at least with the roots that are there. Now we need to know how stretchy it is. We need to solve for our a value. In order to do that, we need to use one additional point. Okay, one point that's not a root. And it looks like there's one labeled already here. Okay, so this is the point 0, 16. Keep in mind, this is just an xy coordinate point, right? So we're going to use 0 for x and 16 for y as our one additional point, and we're going to plug it in for x and y in our equation, and there should just be a left. Okay, so p of x is like our y value, right? So 16, okay, that's me plugging 16 in for y, is equal to a, we don't know, and x is 0. Okay, I'm using 0 for x. Okay, so 0 plus 2 squared times 0 minus 2. So now I'm just going to use my simplification skills, use order of operations, right, PEMDAS, to simplify what I have and solve for a. Okay, there's nothing I can do with this 16, but inside the parentheses, 0 plus 2 is 2. 0 minus 2 is -2, and I'm just slowly starting to simplify what's there. 2 squared is 4, and then I'm pretty close to being done. Okay, 4 times -2 is -8, and that a is being multiplied, right? So now I'm just one step away. So if I divide by -8 on both sides, that should isolate the variable a. Okay, so our stretch factor for this equation is -2. So now what I need to do is take this stretch factor that we've solved for and put it into the original equation that I built, right? So this equation right there, okay? Because that's the equation that has my roots built into it, but it was just missing the stretch factor. So my final equation would be p of x is equal to a, which is -2, times my roots. So x plus 2 squared times x minus 2. Okay, so this would be the graph that, or the equation, I should say, that exactly fits this graph. Okay, it's the right stretchiness, right? It's the right steepness. It goes through the point 0, 16, and it hits those 2 spots on the x-axis. And we could certainly check that by taking this and putting it into Desmos and making sure this graph is what it shows up. Okay,